in the field.
Okay.
In the meantime, we can check if the live will be published.
Okay, great.
Yeah, it is. I just checked. I will stop unless because it has some delay, and I mean, hearing what I said a couple seconds later is kind of annoying.
Yeah. I'm gonna just turn the volume down on that to mute it. Great. And I'll share it on Twitter.
I'm gonna do the same.
Still up, I just want to back here. Okay, great.
Yeah, so hopefully. All right. Let's see if someone will join us.
Okay.
And all right, so it seems to be everything working. If we're ready, we can get started.
Great. Yep.
All right, so let me just do this final thing here. Okay, cool. Hello, everyone, and welcome to Castálio Podcast episode 142. I am Eliezer Rezende speaking from Chapel Hill, North Carolina. Before we start, I want to share with you that we have a permanent 40% discount code that is good for all many products in all formats. So this is an offer that many publisher give to you all. Feel free to use it as much as you want. The code is PODCASTALIO19, PODCASTALIO 19. So with this code, you can get 40% discount on any product. Also, on this episode, we'll be giving away 5 ebooks, copies of the class Computer Science Problems in Python. This giveaway is going to work this way. We'll be giving 2 copies for people that are participating live with us, and 3 copies that will be given away to people that listens the episode later on when it's released. So to enter, you're going to fill a form and answer some questions about the book. And the book, by the way, is the theme of this episode. You can find the link of the form on the episode's show notes, so make sure that you enter to being able to get that free copy. We are going to pick up the winners live. So if you don't follow us on YouTube, make sure that you do so you can follow the pickup when we do that. And also follow us on Twitter, because we also notify there whenever we have a new episode or a new live event. For people that are watching us live, we will paste the link to the forum in the live chat in a few. So be aware that if you enter the giveaway, the live giveaway, you won't be able to participate when the episode is released. The good thing is that usually we have fewer people live than listening the episode later on, so you get a higher chance. So that's why you cannot also get the other chance as well. All right, so since we get the discount code and also these 5 copies, I think we can get started to our episode. So our guest for today's episode is an assistant professor of computer science and innovation at
Champlain College.
Thank you.
Mm-hmm.
At Champlain College in Burlington, Vermont. He's the author of Dart for. Oh, I cannot speak today. Sorry about that.
That's okay.
He's the author of Dart Absolute Beginners. I said it wrong again. He's the author of Dart for Absolute Beginners, Class Computer Science in Swift, and the recently released Class Computer Science Problems in Python. Also, he is active in open source community as the author of the several popular Swift data structures projects. So make sure that you check his GitHub out. We are going to leave the link on the show notes. And it is with a great pleasure that we welcome David Kopec to our podcast.
Thanks for having me. It's really an honor to be here, and I look forward to having a great discussion.
Sounds good. So let's just get into it. Usually we like to start our episodes, kind of learn a little bit more the background. It won't be different with you, David. I hope you don't mind. So can you tell us, how did you start on the programming world?
Well, I was really fortunate when I was growing up that my dad was actually a computer science professor. So when I was a small child, like 7 or 8 years old, he started teaching me programming in BASIC. And so I started with BASIC, and I kind of just never stopped. So I went through BASIC. Then when I was a teenager, I got into Java. And then I got into Objective-C and building Mac apps. And eventually, after college, I didn't actually study computer science in undergraduate, but then I went back to graduate school and did computer science. And then that's when I actually got into Python, was when I was in graduate school studying computer science.
Cool. And it seems that more and more schools, they are adopting Python as the first language, which is really good.
Mm-hmm. Yeah, it's happening a lot I saw a chart a few years ago of the top 40 universities in the United States and what language they use in their first computer science class. And Python was now in about half of them. So I thought that was pretty impressive, considering that just, 20 years ago, it would have all been C++ and Java and C. So Python's been growing immensely in undergraduate computer science programs. And I think it's really a testament to what a great teaching language it is.
Yeah, I'm really impressed that Python is growing more and more as the day passes. One thing though, you've mentioned that you came to the computer science course, but what really made you make that decision? And okay, I'm doing computer science.
Well, I had always been interested in programming, like I mentioned, since I was very small. And computer science is the formalized discipline that you study if you really want to be a professional programmer, professional software developer. So it just made a lot of sense. That said, computer science is not just programming, of course. There's a lot more to computer science than just programming, but the reality is that the vast majority of people who study computer science do so to become programmers. So it was a natural fit for me. I didn't do it in undergrad because I thought I was interested more in business. And after I graduated, I went and worked on Wall Street, and I really hated it. I didn't even do it for a year. I quit before a year was out, and I went to graduate school. So I was a little bit of two minds, and maybe I'll combine the two back together again later in my life and do a tech business. I did a little bit of that before I became a professor. So I like to think that both backgrounds, economics, which is what I studied undergrad, and computer science in graduate school, have some kind of synergy for me in life. But computer science is my number one passion.
Cool. Can you tell us a little bit more about computer science? Because most of our listeners, they are Brazilian, and I think the concept is a little bit different because usually on Brazil, when we study computer science, is people that maybe will pursue doing researches, not like to work professionally. We have some other courses that focus more on that area. So could you explain a little bit more if there is the case here, like there are some courses that is intended to do to be done by people that is looking for doing research in the future, or if you do computer science, you can do both, business or research?
Yeah, sure, absolutely. So computer science is using computational tools to solve problems. So that's a really broad definition. But people who study computer science in the United States, at least, the vast majority of them become software developers, at least at the undergraduate level. So I teach in a computer science program in Vermont, which is a state in New England in the United States. And I would say 90% of our graduates in the computer science program go on to work as a software developer. Now, that being said, you're right that a lot of people go on to research too. Our school is more of an applied program, so it's more for people getting ready to join the workforce. But if you're going to graduate school in computer science, it might be because you want to be a researcher. It also might be because you want to actually end up at a higher level job in industry. But as a whole, computer science is broader than just software development. It is there's a lot of sub-disciplines of it. Things like algorithms and data structures, artificial intelligence, computer vision, computer graphics. And so it's not just about how do we program these systems, but also what kind of mathematical constructs and what kind of problem-solving techniques can we use to reason about these systems beyond just building them. So computer science is a broad term, and software development is just a subset of the applied areas of computer science. But all of that said, in the United States, the vast majority of people who get undergraduate computer science degrees go on to work as software developers.
Cool. Thank you for the explanation. And if you allow me, I'm going to make a pause about the computer science theme, because one thing that brought my attention by looking for your bio was that you are author of 3 books, right?
Mm-hmm.
So what made you decide to write a book?
Well, when I wrote my first book, which was called Dart for Absolute Beginners, that was in 2013 that I was writing it. And the Dart programming language from Google was just coming out back then. It was in beta at the time, and it was coming out in its 1.0 form. And I was working in kind of the startup industry for a couple years after I went to graduate school. And I was really excited about Dart. I didn't really have much of a background in computer science education, but I thought this looks like a really cool language. Maybe there's a way to be the first person to write a book about the language for people who have no background in programming. And then if the language ends up being successful, it'll end up being an important book. Now, what happened is that the Dart language, as probably most of your listeners know, didn't really take off. It didn't become one of the biggest languages in the world or anything like that. So I think I wrote a good book, but unfortunately, it didn't have a lot of readers. It was published by A Press in 2014. But what it did do for me was it started me on this journey into computer science education. So it started with that book, and then I started adjunct teaching at a community college in New York. And then a few years later, I saw this job opening to be an assistant professor. Specifically, they needed somebody with mobile app development experience here in Vermont. And that's what I'd been working in the startup world, was building mobile apps. So that combined with writing the book and having done some adjunct teaching kind of all came together to take on a full-time role in computer science education. So I don't want to go on forever, but that was my first book. And then a couple years ago, in 2016, I wrote the book Classic Computer Science Problems in Swift. Obviously doing a lot of mobile dev. I'd done a lot of work in Swift. And again, it was something where I thought maybe there was a niche for this, because there were a lot of books on Swift. There were a ton of books on iOS development with Swift. There weren't a lot of books about computer science with Swift. And so my book was one of the first of a wave of books about computer science education written in Swift. And then the Python book, which just came out a couple months ago, that was a natural progression from the Swift book. So we took the Swift book and we wanted to make it available to a wider audience, because while Swift is popular, it's obviously nowhere near as popular as Python. And so we took the Swift book and we said, if we're going to port it to Python, we really have to make it very Pythonic. So me and the publisher, which is Manning, put together a team of people who were really experienced in the Python world. And we made sure that we wrote a book that was truly using the best practices in Python instead of just feeling like a port of the Swift book. But that being said, a lot of the concepts, the algorithms are the same going from Swift to Python. So while all the code changes and all the explanations of the code have to change, the explanation of the algorithms and kind of the broader computer science topics could stay the same. So that was kind of the journey I went on. And so I would say all three of the books were planned. The last one, the Python book, was a really natural progression of the Swift book.
Cool. I was checking about Dart because it has been a long time that I don't hear about the language, and it seems that they released the version 2.3 May 8th, which is like interesting. So I don't know. It wasn't. I was also excited when the language went out, but yeah, I mean, it has been a long time that I don't heard anything about the language.
Yeah, I mean, so when the language first came out, there was this promise that it was going to be included as a virtual machine inside of Chrome. And then they backtracked on that promise in 2015, and that led to interest in the language just plummeting because people thought, oh, this is going to be an alternative to JavaScript, right? And what it really turned into is here's just a way of transpiling from one language into JavaScript. So interest in the language really waned at that point. But then with Flutter, the last couple of years, interest has picked up again. And I think there's a lot of excitement around Flutter. I don't know if people are excited about Flutter because of Dart, or they're just excited about Flutter because it seems like a good cross-platform framework for building mobile apps and web apps as well. So the language itself, its performance in terms of becoming popular has been kind of lackluster, but Flutter's kind of giving it a boost in the last couple of years.
So this is the first time that I hear anything about Flutter. I would check it out.
Yeah, it's like React, but so React Native, right? React Native lets you build cross-platform mobile apps in JavaScript that are actually, pretty well, can be pretty well tailored for iOS and for Android. Dart is similar. It has a bit of a different model in that instead of really linking up into native components, it has its own abstraction layer, its own graphics routines that are a layer above the operating system. So you really can get something that's quite identical on both platforms. But again, it's tied to the Dart language. So you do have to learn the Dart language to use Flutter. So that might be one of the only reasons that Dart is kind of picking up again. I mean, I don't want to sell Dart short. Like, I'm not really very involved with Dart anymore, honestly, even though I wrote the book about it 6 years ago. When they announced they weren't going to include it in Chrome, I personally started to lose interest. And I was just working a lot in the iOS world. And so I just kind of fell out of it. It wasn't because I didn't like the language. I really do like the language. But it's just, doesn't seem to be, other than Flutter, a big niche where people are saying, Dart is really the thing to fill that niche. So hopefully, I hope for the team at the Dart team that Flutter does really well for them. It's certainly, I'm seeing a lot of new books coming out about it, and I'm seeing people talking about it more. So it's certainly picking up some steam.
Thank you very much for the class about the mobile related languages, because I just got curious. I know that this is not our focus here, and we are going to come back to our focus of this episode, but thank you very much for giving this class to us.
Sure. Sorry, I hope I didn't go on too long.
No worries. You're fine. By the way, before we talk about your recent published book, I want to know, how was the process of writing the book? You can speak about that in general, since you wrote 3 books already. I'm kind of more interested about the Python one, and also what technology have you used to write it? Is anything special required? I like personally to ask this because, I don't know, the idea behind this podcast is try to inspire people, and maybe knowing a little bit more about the background and the tools would help like that person that's almost doing it to do it. So that's why I kind of like to bring this type of question. And yeah, I hope you don't mind me asking this before we
Sure.
go to talk more about the book, because I'm really excited about that as well.
Absolutely. So I think a lot of people would be surprised about how primitive the tools actually are that are used by a lot of the major publishers. So when I wrote my book, Dart for Absolute Beginners, in 2014 for A-Press, 13, 14, they were still using Word templates. So literally, they will send you a Word document, and it will already have some preset formatting in it. And then you're going to fill in your chapters using all of their preset formats. And then when you have source code, you can be doing that in whatever integrated development environment or whatever editor you want. And then you're literally copying and pasting that source code into those Word documents. I know that sounds very, very primitive, and truly it is. It's actually very frustrating. Then when I did the Swift book in 2016, 2017, Manning had two options. They offered me Word templates, again, or they offered me to work in a format called ASCII doc. And ASCII doc is a text format that's not too dissimilar from Markdown. And I'd had a lot of experience with Markdown, so I thought, okay, I'll try working in ASCII doc. Unfortunately, the tooling around ASCII doc was not very mature. And it didn't really, I'm not sure it really saved me any time working in ASCII doc instead of working in Word templates, because some of the tooling, especially the tooling for, let's say, taking your ASCII doc document and turning it into what the eventual book will look like, was just not very mature, at least the tool set that they were using at that time. And so in the last book, on the Python book, I went back to using Word templates, and they actually recommended that to me because they said their tools for that are more mature. So I know it's not a very sexy answer, but honestly, I wrote 2 out of the 3 books in Word because that's what the publisher preferred as the format that I use. For editing the source code, I do all my Python work in PyCharm. And so PyCharm is a great companion, I think, for everybody. But when you're writing a book, it's a good companion too, because it has a lot of good hints and good, it has a built-in type checker. So it's pretty powerful tool for debugging as well. So PyCharm was very helpful to me. But again, it was just me copying and pasting source code from PyCharm into Word documents because that's what their tooling is. Now, that said, I know that some other publishers have some, and I'm not putting down Manning in any way. I know they're working on improving their tools. But some other publishers I know have some much more advanced tools around Markdown and Git. And so the idea where, let's say, every time you publish a commit to your Git repository of part of the book, it auto-generates the PDFs of what the book will automatically look like in the future. So some of my friends who've written for other publishers have worked with, let's say, some more modern tooling. But a lot of the publishers are still working with Word documents. I hope that was the right type of direction that you were looking for in terms of tools.
Yeah, sure. Actually, I mean, this is like to show to people that if you're willing to write a book, if you have Word or any editor, that is enough.
That's true. Yeah, it
so
really
I mean,
is.
was a really good answer, by the way.
Thanks.
Okay, cool. So let's talk more about the class computer science problems in Python, which is kind of our star of today's show. So, I mean, I think we can start with what is the intended audience? So you've mentioned the computer science classes and teaching Python and whatnot. So is that the audience or anyone else, or there is other specific audience that the book was intended, or do you think that the book will fit?
Yeah, I'd say there's 3 audiences. Number one, and this is the most common one, is self-taught programmers who never really studied computer science in a formal way. Now, I should preface everything we're saying by saying that the book requires at least an intermediate knowledge of Python. It's not a beginner's book. So it's not a book for somebody who's just learning programming for the first time. We assume that you already know how to program in Python before you pick up the book. But what I hear most for the most common reader is self-taught programmers who never took computer science classes in college or on their own, And so they want to know more about some of these computer science topics without having to go to school, of course. And I think that's the point of the book. The point is that the book is a broad overview. It's not deep. It's a short book. It doesn't go into a lot of depth on any of the topics that it covers, but it at least makes you familiar enough with them so that you know what those topics are for. So self-taught programmers is the number one audience. Number two is students. So I do hear about some students in college who are doing computer science, and maybe they're learning in a different language, or they just like how succinct the book is, or they've heard good things about it. So students in computer science programs is a second audience. And the third audience, I've heard about some old school, long-term software developers who want a refresher on some of these topics. So maybe they've been programming for 20 or 30 years. Maybe they actually did study computer science in school, but they haven't really engaged with these topics in a very long time. And so they want a bit of a refresher. Sometimes it's for job interviews. You know, we hear a lot today about people going to job interviews and having to perform an algorithm on a whiteboard. That's very common. And a lot of those algorithms that you hear about having to do on a whiteboard are in this book, actually. So some people are using it for interview preparation, even if they already have learned this stuff a long time ago. So those are the three audiences, I'd say.
So you can count me on the third audience because I just ordered the book. I need a refresher, even though I graduated on 2011. It's like not 20 years or so, as you've mentioned, but I think I need a refresher because I was looking the table of contents and okay, I've saw those things, but I can't really remember. So I think it would be good to see those in Python, because I love Python, and also kind of refresh my mind on those topics. So yeah, hopefully I'll get the book on my hands soon.
Absolutely.
Okay, so I mean, since I'm already excited about the book, let's talk more about the content. So what problems are you showing how to solve on your book?
Okay, so it's going to be kind of a long answer, so I'll preface it with that. The way that we thought about what is a classic computer science problem, we first thought these would be problems that anyone who has a computer science education would be familiar with. So problems that when somebody does an undergraduate degree in computer science, they typically see at some point throughout that degree. So that was our first criteria. Now, it turned out that that was not enough problems to really fill a whole book, just enough that everyone would have in common. So we went beyond that and we thought, what problem-solving techniques should everyone who works in software development from the world of computer science be familiar with? So we took it and we said, okay, we're going to use a lot of classic problems, but sometimes maybe there's not a problem that really fits this problem-solving technique. So we'll need to just make up a problem that goes with that problem-solving technique. So we stretched the title a little bit. In terms of what techniques we actually cover, it's kind of a long list, so I'll go through it pretty quickly. But in the first chapter, we do background stuff that like recursion, memoization, operating at the bit level, basic techniques that everyone who works in software development has probably seen at some point. In the second chapter, we cover search, things like breadth first search, depth first search, A-star search. In the third chapter, we cover constraint satisfaction problems. So those are problems where you have some variables. They could take on a bunch of potential values. We call those domains. But there are some constraints between the variables. So there has to be something about the relationship between the two variables has to be true in order for the problem to be solved. And that's actually a technique that kind of comes from artificial intelligence a little bit. In the fourth chapter, we cover graph algorithms. So those are, you can think about them as algorithms for working with networks. So anytime you have nodes and edges, everyone who's studied math knows what a graph is. But if you haven't studied math, you can think about it like, I often use the example of the subway system, and we use that in the book as well. So you have a bunch of stations, they have tunnels between them, and people can travel from one station to another across those tunnels. Let's say we want to have algorithms that can find the most efficient route from one station to another, or that can find the way to connect all the stations with the least amount of tunnels. Those are what the type of things that graph algorithms are useful for. But there's a lot of things in the world that can actually be represented as graphs. You think about a computer network, that's a graph where each of the computers is a node, and the wires or wireless connections between all the computers, those are the edges. So there's a lot of different things that can be represented by graphs. In the 5th chapter, we talk about genetic algorithms. In the 6th chapter, we start to do a little bit of machine learning. In the 6th, we do k-means clustering, which is a way of, I have a bunch of data. Can we figure out some natural groupings of the data? In the 7th chapter, we cover neural networks, and it's a introductory level chapter on neural networks. So people who have no background in them can hopefully get a sense by the end of why they're so powerful, why they've been able to be used for things like image recognition, speech recognition, and just a basic understanding of how they work. And then in the 8th chapter, we cover adversarial search, which is like, how does a chess playing program work? Or how does a checkers or any kind of 2-player game, especially board games, how do they actually come up with the best next move? That's what that's all about. And then we have one more chapter of miscellaneous problems. So sorry for the long answer, but it's a really broad book. There's a lot of different topics. It's kind of all over the place. The criticism that some people have had of the book is that it's not deep enough, that you're not going to read this book and be an expert on neural networks, obviously. That wasn't the goal. The goal was to just give you an idea of how each of these things work, show you some real code. All the code in the book is from scratch. We only use the Python standard library. We don't just add a library and say, oh, now you run the library. Everything is just built just using the Python standard library. So we show you how you actually could build your own neural network starting from nothing, or how you can build your own graph algorithm starting from nothing. Now, in the real world, is that what you're going to want to do? No, you're probably going to want to find a good library and use it. We don't want you building everything from scratch. There's great open source libraries to use. But before you use them, you should know how they work. And that's the point of the book, is to give you a bit of an idea of how they all work.
Okay, cool. Yeah, and also, I mean, if you know the basics, it will make you understand whenever you face any issue, because usually when you need or you feel that you need the basics is whenever you encounter an issue. So yeah, it's good to have this kind of first step, or knowing the basics, so that whenever your library provides you an issue because you're not providing the right input, for example, it will somewhat give you more background, so that you can debug it and you can find the problem as soon as possible and get it running. So yeah, I think it's a good approach for the book, in my opinion.
I mean, I agree with you 100%. I think it's very dangerous to use something that you don't really understand. And so we're not saying to everybody that you have to be an expert on all these topics. We're saying that, you should at least know, like you said, the basics of how they work, so that when you use a library and it malfunctions, or before you even use the library, which library should you be using, right? Should you be using a genetic algorithm to solve this problem? Or should you be using maybe a search algorithm to solve this problem? How do you know that if you don't know what a genetic algorithm is or what a search algorithm is? So I think that before you pick a tool, you should at least know what it's good for. And that's kind of the purpose of the book.
I agree. And if you allowed me, what chapter was more challenging to write?
Well, that's easy. By far, the hardest chapter to write was the neural network chapter. Now, there's a lot of great resources. Neural networks are so big right now. There's a lot of great resources on them. So I had to think, what could I provide that would be different than the many, many resources on neural networks? So 2 things. One was, we really do ours completely from scratch. So we only use the Python standard library. We don't even use NumPy. And maybe we should have, but most tutorials on neural networks start with NumPy. So we really show you how everything works from first principles. Number 2, we wanted, even though we were doing something from first principles, it to actually show you something real. A lot of these tutorials on neural networks, they show you finding the sine equation, or proving that a neural network can model this, the sine function, or finding something that has a single neuron and turns something on or off. But we actually do classification problems. So from nothing, within 30 pages, you go from knowing nothing about neural networks to being able to classify wines, classify different flowers. So I think that's pretty powerful. And then the last thing is the scariest thing about learning neural networks for some people is some of the math. And so we really tried to make it as math friendly as we could, but still had to we had to have some basics. You can't do any neural network back propagation is the algorithm that neural networks use for learning. You can't do back propagation at all without knowing at least a little bit of calculus. So we had to have a little bit of calculus in there at least. But my hope is that even people who are a little scared off by, let's say, the calculus can read through the chapter and still get the gist of it, still kind of understand the main themes and what's going on, even if they don't understand some of the very specific equations. So we tried to, I don't want to say that we dumbed it down, but we certainly tried to make the chapter as approachable as possible to people with not a very deep math background.
So we have Eduardo Mendes here on the chat. He's highlighting that, before I forget, I have to congratulate David. In all chapters, the drawings are amazing. Explain the essence of the problem. So Eduardo Mendes is highlighting that you provide some drawings where, according to him, helped a lot to understand the problems.
Well, I just want to thank him very much. That's very kind of him to say. And I can't take all the credit for that. My wife helped me draw some of them, and my publisher also went and, of course, they do the final version. So I usually sketch them out. Sometimes my wife helped me. Sometimes my mom even helped me, believe it or not, when she was visiting us. And then the publisher goes and, of course, corrects them and makes them really look ready for print. So they do a lot of the heavy lifting on that.
So another thing that brought my attention to your book is that you say that it is written on Python 3.7, which is a really recent version of Python. So what made you choose it instead of any previous version?
Well, the main reason is that there's some new features in Python 3.7 that I really wanted to take advantage of. I'll tell you, let's say, 3 features. One is f-strings, and that might have actually come about in Python 3.6, but I really enjoy them, and I think that they are much easier to use than some of the previous ways of doing string interpolation in Python. The next feature is data classes, and we use that in a couple different parts of the book. That's just a convenience feature. Both of those, of course, are convenience features. We could live without them. But since you're buying a book in 2019, we really wanted to use 2019 features. And then the last feature, and this was a big one and also the most controversial one by far, is type hints. We use type annotations throughout the entire book from the beginning to the end. And honestly, that is the #1 criticism people have of the book, is they say, I think I don't like type annotations, or I don't use type annotations myself, and I find that they really add some bulk to when I'm reading the book. They add some bulkiness. And I have to agree with them. They do make the code a little longer, putting in those type annotations. And so if you've never seen them before, it takes a little bit of getting used to. The reason I use them is that I think in some instances they provide more clarity than not having them. For example, with a type annotation, you immediately know what the return type of a function is. And you don't even have to go read through the documentation of the function. You don't have to go look for where the return statement is and then go work backwards and figure out what that thing is. You immediately know. You read the first line of the function, you know what it returns. So I think once you get used to them, and this is my personal opinion and not everyone agrees, once you get used to them, they actually make your code more readable. That's my opinion. But not everyone agrees with that. And so one of the criticisms has been that the type annotations make some of the code a little too bulky. And so what we did is we added an appendix to the book. Appendix C explains type annotations and why you might want to use them. And so for people who've never seen them before and you start reading the book and you're kind of like, what is this? Maybe turn to the back, look at Appendix C, and then come back to where you were, because I think it gives a little justification. But the main justification, again, is that I personally think they make the code more readable, but I can see how, if you haven't seen them before, for some people it takes some getting used to, and they don't look that great maybe the first time you see them.
I think that kind of fit the purpose of the book. So if someone that have never seen this kind of stuff before, just start reading it. I think it will help a lot. And usually, if you are importing those on your editor, such as PyCharm, for example, the editor itself will benefit from those type hints. So it's a good thing, and it will also will provide you better auto completion and things like that. So yeah, I only see benefit. I know that it's kind of, I would say, unusual in terms if you are used to previous versions of Python. I myself I am not really using type hints at all right now, but this is something that I'm planning to start using because first, the benefit of the auto completion, and second, if you go away from your code for some time, when you come back, you immediately know like what is expected from that function, what are the parameters that you expect, the types of the parameters. Of course, you can expect object if that is the case, but it's not always the case. So it kind of like short documentation is something that I consider those type hints, because you don't really need to read the entire doc string, for example, if you have any at all. So that will help you understand how the functions and how to call it, what it returns, and things like that. But yeah, I think it was a really good call from you.
Well, I appreciate that. And like you said, it's a way of kind of self-documenting. So if you're using type hints, you probably have to write less comments around your code. Like you don't have to go explain in your comments, here's what this variable is supposed to be, here's what these parameters are supposed to be. So in some ways, it actually saves you in comments what it might hurt you in terms of the verbosity of how much you have to actually write of code. So it's a trade-off. And again, not everyone is thrilled about it. Again, it's the number one criticism I get of the book. On the other hand, there have been some people who've said, thank you for including them because I found the book a good introduction to them. So, you know, I was thinking about learning them anyway, and I read your book, and now I know type hints. So it's not everyone's cup of tea, but hopefully on balance, it works out for most people.
So another thing that I want to talk about is usually I have read some computer science books before. Usually they come up with some examples that are not like real world examples. And sometimes they are just made to explain something, and probably something that you'll never see a good usage. Do you do that same approach on your book, or do you provide a different type of examples?
Well, you're absolutely right. A lot of the classic problems are kind of toy examples. So you think about, I'll just name a couple problems that a lot of people might be familiar with. The towers of Hanoi. It's you have these disks, they're on some tower, and you have to move them from one tower to another tower. No one's ever going to need to solve that problem in the real world. Or another one is called Missionaries and Cannibals. You have a bunch of people who are trying to cross a river, and some of the people don't like some of the other people, and so they can't be in the canoe together. Again, it's a classic problem, but no one is ever going to need to solve that in the real world. Now, there might be problems, though, in the real world that are kind of similar to those problems in terms of how you solve them, even if they might have no relation to what those problems look like from the outset. So I do think that toy problems are useful in the fact that they are easy to digest and they're small enough that we can think about them and reason about them in a small amount of space. But all of that said, we need to tie what we're using, those problem-solving techniques, back into the real world. And so every chapter, we put in a little section called Real World Applications. And it explains the techniques you learned in this chapter. What are some real world problems that they're actually used to solve? So for example, we talked earlier about the neural networks chapter. In that chapter, we classify wine and flowers. Now, probably you'll never need to in your career classify wine and flowers. But we explain how you can use the same techniques in the real world to do things like image recognition or speech recognition, which are real world things that a lot of people need to do all the time. So toy problems, I think, are useful because they're small enough that we can think about them. And sometimes they're fun, so they kind of keep you engaged just because they're fun. But we do need to always tie things back to how is this actually useful? I'm not going to be actually moving disks around towers. So how can I actually use recursion in the real world? So I agree with you that it's sometimes frustrating to some people that these problems don't really seem like they're that useful. But we really tried to make the problems be the starting off point to explain the problem solving technique and then have some explanation of how you can take it to the next level for some real world problems.
That is really good that you bring those up. So, I mean, I think we got good coverage on the book subject. And Andrew Rivers, he's asking if you have decided what is going to be the next book on the classic problem series.
Well, thanks a lot for the question, Andrew. It's been a big debate between me and the publisher. So the Swift book did okay. You know, it sold enough copies that they were pretty happy with it, and I was fine with it too. The Python book's been doing really, really well. The Python book just came out a couple months ago, and it's just selling amazingly. Right now, it's the best-selling book on Manning.com. For a little while, it was selling very well on Amazon too, but they ran out of stock. They sold so many copies. What's weird is that we don't have a lot of reviews on Amazon, even though we ran out of copies on Amazon. But anyway, the book's been selling very well for the publisher. So of course they want to do another language. And we ran a poll of our readers on Twitter, and we actually got 300 responses because Manning retweeted the tweet. What language do you want the next book in the series to be? And surprisingly, the Go actually came in number one, with Java like almost tied with it. So Go and Java were the most popular responses. Now, just because that's what people voted on doesn't mean that's what we have to do. But honestly, that's the two languages I was thinking about anyway. And I went to the publisher, and the publisher really strongly wanted to do Java. And I actually wanted to do Go. And so we had kind of a back and forth for a few months now about whether we should do Go or we should do Java. And they've actually, I have to be honest with you, some people will be disappointed, but they've convinced me that Java might be the better way to go. And I'll tell you why. We did the Swift book, and Swift is a rising language. It's becoming more and more popular each year. It's in the top 10 list by most measures of most popular programming languages in the world. So Swift is in the top 10 list. Go is rising too. Go is, by some lists, it's already in the top 10. A lot of lists in the top 15. So Go is rising. Python, by some measures now, is either the most popular language in the world, or it's certainly in the top 3 by certain other measures. So it depends what you look at. There's the Toby index, there's number of GitHub repositories, number of Stack Overflow questions, there's RedMonk index. There's so many different indexes, but Python's certainly a top 3 language, no matter how you look at it. So here's what I'm thinking. We did a book that for a language that was rising before Swift, and it sold okay, but it didn't do, out of this park well. We did the same book in Python, of course, making it very Pythonic, like we've talked about, using all the latest Python features, and it's been doing amazing. And so does it make more sense to do the next book for a language that's already one of the top 3, Java, or do the book for a language that's rising and try to be in that niche again? Honestly, in terms of sales and in terms of, how well it's done, Java is starting to make more sense to me. So it's going to disappoint some people who were looking forward to the Go version, which we have, talked about maybe we would do. But I think Java is probably going to be the next version. And there's people who've wanted C#, there's people who've wanted Kotlin, there's JavaScript aficionados who've reached out. There's been a lot of different ideas about what we should do next, but I think Java is probably going to be it, just because I think we should cover maybe the most popular languages first, and then we'll go back and fill in. If the series is still doing well, we'll go back and maybe do Go after Java.
So we got some suggestions here on the chat.
Okay.
Andrew said that he voted for C++ before, but he has changed his mind to Rust.
Okay.
And Eduardo Mendes is say about Haskell.
Yeah. So interestingly, on the C++ side, we've had somebody actually translate the first 5 chapters of the book into C++, and you can find that on GitHub if you're interested. C++, not my personal favorite language. And when you write a book about a language, you really need to like it, because you're going to be spending a lot of time writing that book. And I'm just not in love with C++. Now, Rust is interesting, and Rust is certainly rising in the same way that Go and Swift are. But I think, again, when you write a book, you have to be an expert in the language too, right? And I'm not an expert in Rust, so I'm probably not the person to write the book in Rust. That being said, if there was somebody who wanted to be a co-author and reuse a lot of the English explanations of the topics, but translate the code into Rust, I'd be open to approaching the publisher about that. And I've thought about that before. So unlikely that Rust, though, will happen next, but I appreciate the suggestion. Haskell, very unlikely. It's just not a very, I had to do Haskell in school. I don't dislike it or anything, but it's just not a very popular language if you look at these indexes. It's, you don't want to be a niche within a niche. This is not like a book that every single software developer is going to buy. This is a book for a certain subset of software developers. And so it's nice to be in a niche within a big language like we are in the Python book. When we were a niche within a niche, where we were a niche within Swift, it's not as easy to really make the case for the book. So to go to a language even smaller than Swift, kind of probably not a great direction for a book that's such a niche. If your goal is sales, and even if my goal isn't sales, right? I work as a professor, so my number one goal is not probably sales. My number one goal is probably how this helps my career, and I want to teach people as well. So there's that benefit. But I want to reach a wide audience still, right? I don't want to write a book that nobody's going to read. So I have to balance all these things. And the publisher, they really just want sales. I love Manning. They're great, of course, but they're not going to publish a book that they don't think is going to sell well. And so to write a book in Haskell right now about a niche topic, it's a long shot in terms of convincing the publisher that that's a good idea.
Fair enough. So I'm going to surprise you with one question here. Okay. So past week when we tried to record this episode and Hangouts on Air was just not working, Augie Maciel was planning to participate with us, and he left one question. So this is something that hopefully I'm going to surprise you on a good way. So we were looking on the Oak Snow, which is your consultancy company, right?
Yep.
Okay, so we found one thing called Sea Turtle.
Yeah. Okay.
So Augie left this question for you. Can you tell us a little bit about Sea Turtle and what are some of the coolest projects that you've seen people do with it?
Okay, it's a cool question. I really appreciate it. It's not a great answer. So I'll tell you what Sea Turtle is. Sea Turtle is a logo-like programming environment for kids that I built, and that was released on the Mac App Store in December of last year. So it's not exactly the same as the Logo language. It's kind of a cross between Logo and Basic. And for people who don't know Logo was a very popular language in the 80s for teaching programming, where you have a little turtle and you tell the turtle, move forward, turn right, turn left. And every time the turtle moves, you get a little line behind the turtle. So he's making a drawing. And so it's a way of teaching programming by teaching how to move this turtle. So I built this Sea Turtle programming language to teach young people how to program. And I didn't do a ton of marketing. And so I haven't sold a ton of copies. I've sold, I think, about 100 copies. I charged like $5 for it. So I've had $500 in sales or something selling this programming language. And the reason it's a bad answer is that I haven't gotten any emails from users who said, here's this really cool program I built. So the best programs I know are still the example programs that I included with it. So unfortunately, I wish I had some great, you can export animated GIFs of your programs. I wish somebody would share with me a really cool animated GIF that their son or daughter made, but I haven't received that yet. So sorry, but thanks for asking. I've lost your audio. There we go.
Sorry, I was on mute.
Okay.
Okay, so thank you for the answer. It was good to know more about it. And yeah, I mean, if you played with Sea Turtle, make sure to share with Dave later on.
Yeah.
So yeah, we had this long conversation and really good conversation, by the way. So thank you very much so far for that. And we are going to come up to the top 5, which is a section that we like to have here on the show. So this is kind of learning more about yourself, David. So do you mind sharing your top 5 of books with you?
I thought a lot about that, because you told me we might do a question like this, and so what I read a lot of books. So what I decided instead is I would just give you the 5 books I've read most recently. So I finished recently reading *The Republic* by Plato, which most people read in high school in the U.S., but I just never read it, and I thought it was a great philosophy book. And even though it might not be completely applicable to the world today, I enjoyed reading it. I read *Creative Selection* by Ken Cosienda, and that's a book about how Apple works from a software developer's point of view. So what's it like to work as a software developer at Apple? I read a book called *Game Over: How Nintendo Conquered the World*, just for fun, just learning about how Nintendo rose to be prominent in the 1980s in the United States. And I read a book called *Algorithms*, kind of relevant to our topic that we're talking about today. It's a textbook that I'd used years ago, and I thought I should finally finish reading it. It's one of the most popular algorithms textbooks in the world. It's *Algorithms* by Sedgwick and Wayne. It's a very good textbook, different from my book. My book is not a textbook. And then right now I'm reading a book called *The Abolition of Antitrust*. And it's about whether or not antitrust laws are actually a good thing. I don't think the author has convinced me that we should abolish them, but it's certainly an interesting book to read. So those are the 5 books I've read most recently.
Great. I took note of all of them, and we are going to share on our show notes. So the next topic on our top 5 is music, and can be also bands, if you will.
Yeah, so I like a lot of classic rock. So I like things like the Eagles and the Rolling Stones. I'm a big fan of Michael Jackson. I like Bruno Mars also. And I also like Elvis. So I like a lot of classic stuff.
Cool. Yeah, I also like Michael Jackson.
Yeah.
What about movies or series, TV series, whatever you watch?
Well, my favorite movie of all time is Forrest Gump, which I just think is a great movie. I watch a lot of kind of reality business shows, let's say. So I watch a show called Shark Tank, which is really popular in the US. I watch a show called The Profit, which is about a billionaire who shows up at small businesses and tries to help them. I also watch a couple history shows. I watch a show called The Curse of Oak Island, which is very popular in the US. It's about a bunch of folks in Canada on an island who are looking for a lost treasure. And it's supposedly, they believe in it and they really think it's there. I don't know if there's really a treasure, but watching them look for it is kind of fun. And then I just watch a lot of kind of history documentaries and stuff like that.
Excellent. So yeah, I mean, we had this really good conversation, as I said before, but usually we try to fit each episode into 1 hour. So we are approaching our time here. So again, thank you very much for being with us, especially for being patient related to the issues that we have trying to record this on past week. So I really appreciate you being patient on that. It was on us. YouTube on air was just like not working that day. It is working today and kind of magically. So it's something on their end. We did everything that we could to bring this up. So for anyone that was expecting to follow us live, again, sorry, we had some issues. It was kind of the first or second time, so it's not usual. Hopefully we'll not have that in the future. Again, Dave, thank you very much for being with us. I want to leave this time and space to you to say anything that you want. Feel free to advertise. Feel free to talk more about anything that you want.
Well, thank you so much. First, I want to say thanks so much for having me on the show. It was really a pleasure. I really enjoyed talking to you the last hour. I will put in a plug for the book's website. It's classicproblems.com, classicproblems.com. So anyone listening who wants to find out more about either the Python book or the Swift book, you can find that on the website. And feel free, if anyone has questions, to reach out to me on Twitter. I'm at Dave Kopec, DaveKopec. And I always love to hear from readers. So feel free to reach out to me.
Cool. And also, we are going to leave all the links and information on our show notes. So make sure to check those out whenever we release this episode. To make sure that you get notified when that happens, follow us on Twitter, and also make sure that you are subscribed to our YouTube channel, where you can be notified whenever we are doing a live recording. So for people that were with us here on the chat, I pasted the link for the giveaway. Thank you very much for being with us. This is an English episode. This is something that we try to bring whenever we have a great person, and today we had. Hopefully you found it a really good episode, as we do. And thank you everyone that followed us here live. And thank you everyone that's going to listen to us when this episode is released. Bye-bye.
Bye.